Welcome to this video on Microsoft Defender Threat Intelligence APIs, application and use.
In this presentation, we'll dive into the use of Microsoft Defender Threat Intelligence, or MDTI, Application Programming Interfaces, or APIs.
These APIs are part of the Microsoft Graph ecosystem, which provides a unified programmability model that you can use to access a tremendous amount of data in Microsoft 365, Windows, and Enterprise Mobility and Security. I'll demonstrate how to leverage the APIs to efficiently operationalize threat intelligence in your environment. By the end of the presentation, you should have a solid understanding of the practical usage, authentication methods, and integration options
for the MDTI APIs.
If you're seeking specific guidance, feel free to use this run sheet to navigate directly to the sections that interest you most.
The Microsoft Graph MDTI APIs enable a wide range of integrations with Defender Threat Intelligence. This includes MDTI integrations with Security Information and Event Management, or SIEM, tools like Sentinel, custom applications, Azure Logic Apps, and reporting tools like Power BI. The MDTI Premium Data Connector for Sentinel seamlessly integrates Microsoft Sentinel with Defender Threat Intelligence. This integration is crucial as Sentinel, together with Defender XDR, act as a central hub for security operations.
Threat hunting and remediation is not something to be done in isolation or in silos. At each stage, you need to be able to connect the dots. To connect threats to vulnerabilities to remediations, to connect incidents to threat actors to remediations, to connect news reports of attacks to incidents and vulnerabilities, and on it goes. But in most cases, you want to end up connecting to a remediation. Since any tool only has visibility to part of the picture, integration with a central hub for analysis is vital. And it is APIs that allow for integrations into such security information and event management, or SIEM systems. These hub SIEM systems can then do the correlation required to connect the dots across the data from these multiple source systems.
Microsoft recommends Sentinel with over 300 ready-to-go product integrations as your central SIEM system. But regardless of your choice, the MDTI APIs allow for such integrations. The MDTI APIs allow you to operationalize the integration with your tools of choice without relying on the user interface or UI.
And they provide those tools with more actionable data like articles and intel profiles, machine intelligence such as indicators of compromise or IOCs, and reputation verdicts, and enrichment data including passive DNS records, cookies, components, and trackers. If we look at the docs, we can see that the DTI APIs give you access to a wealth of data. You can retrieve articles providing what we call finished threat intelligence. You can pull information about hosts and related cookies, passive DNS entries, reputation, and more. You can discover referential host pairs observed about a host. Host pairs include details such as information about HTTP redirections, consumptions of CSS or images from a host, and more. You can access information about what web components are found on a host and SSL certificate data observed on a host. You can access internet trackers observed on a host. You can retrieve intelligence profiles about threat actors and their common tools of compromise. You can list DNS and pDNS records about a host, and you can access general SSL certificate data. You can pull the subdomain details for a host, you can get the details about a vulnerability, and you can get the whois details for a host. All of this provides a great deal of potential for enriching other security tools and adding value to custom apps for which this data is relevant.
Okay, let's start digging in. And to start, we'll look at the MDTI API authentication call flow. MDTI APIs are implemented as Microsoft Graph APIs, and naturally, authentication is crucial.
There are two primary methods to obtain the required access tokens. These are delegated access and app-only access. In delegated access, the app acts on behalf of the user and uses an OAuth2 authorization flow to authenticate. That process involves a user who must be present and participate in that process. On the other hand, app-only access allows the app to authenticate without user interaction using client app credentials such as app secrets. Understanding the call flow and authentication for both methods is key to effectively using the APIs.
When using the delegated access scenario and using Microsoft Entra ID for authentication, two common strategies are the interactive browser logon and the device code logon. The interactive browser logon requires a tool that can redirect a HTML response to a browser, delivering a straightforward method where users are prompted to enter credentials in a web browser. It supports multi-factor authentication and is a good choice where a web-based authentication process can seamlessly be integrated into an application's workflow. In this presentation, we'll later see that the Insomnia tool supports this style of authentication, whereas tools like curl and VS Code with the REST client extension do not. On the other hand, the device code login does not require browser integration and is designed for scenarios where direct interaction with the browser is not feasible, such as on devices with limited input capabilities or in environments where browser integration is not available. In this method, the user is provided a code and a URL to enter in a separate browser session or even on another device. It also supports MFA and is ideal for IoT devices, smart TVs, or command line applications where the user can authenticate on a separate browser or device. In this presentation, we'll use it to log in to tools like VS Code with the REST client extension, which lack browser integration for redirecting a HTML response to a browser. Okay, now let's move on and look at call flows.
So, the delegated access method is used to authenticate an app based on an individual user's credentials. It requires user interaction, typically via a HTML UI, to acquire username and password. Credentials granted are short-lived and need to be refreshed periodically.
The app must be registered and authorized to make the request, and the app needs a client secret to be used in step 4 of this process.
Let's step through the flow. 1. The authentication flow starts with an authorization request. The user submits a GET request to the MS Graph Authorize endpoint. This request includes the client ID of the registered app and the scope or permissions requested. 2. The user is then directed to a web page UI to log on with their username and password and potentially multi-factor authentication. Entra ID signs in the user and requests their consent for the permissions that the app requests.
3. All being okay, the authorization request from step 1 returns, providing an authorization code to the app. 4. The app then uses this authorization code and the client secret at the Microsoft Identity Platform token endpoint to obtain an access token and a refresh token.
5. The app then calls the desired DTI API with the access token, which is included in the HTTP authorization header of the API request. 6. The API receives the request and validates the access token. 7. If the token is valid, the API processes the request and returns the appropriate response.
Note that if you have an access token from a previous call, only steps 5 to 7 here are required.
This flow ensures secure authentication and authorization for accessing Microsoft Graph APIs. For reference, this slide provides the HTTP message structure for each of the steps on the prior slide. Later, we will show how to implement these using a variety of tools. Delegated access tokens expire, typically after about half an hour. When the access token expires, you can use the refresh token to obtain a new one. The refresh token allows you to avoid repeated logins and keeps your automation running smoothly. Here's how it works. 1. When the access token expires, the app uses the refresh token to request a new access token using the Microsoft Identity Platform token endpoint. 2. Entra ID validates a refresh token and issues a new access token and a new refresh token. 3. The application can use the new access token in the HTTP authorization header to call the API. 4. MS Graph validates the access token with Entra ID. And 5. If the token is valid, the API processes a request and returns the appropriate response to the app.
The delegated access device code strategy is very similar with the changes highlighted here in yellow. As you can see, it uses a different endpoint and does not provide a refresh token. Again, the device code strategy is very similar with the same changes highlighted. Plus, you can see that the expiration time is about an hour and a half rather than an hour, which compensates a little for the fact you don't get a refresh token, but not much. For app-only access, no user interaction is needed. Here, the application authenticates itself using its app client ID and secret. This requires a registered app with an app secret and that an admin has granted administrator consent to the permissions requested for that app. The steps are straightforward. 1. The app makes a POST request to the Identity Platform Token endpoint to request an access token. In this request, the app or client uses the app client secret. 2. Assuming it is granted, the app receives back an access token. 3. The app then calls the desired Graph DTI API with the access token, which should be included in the HTTP authorization header of the API request. 4. The Graph API receives the request and validates the access token. 5. If the access token is valid, the API processes the request and returns the appropriate response. Note that again, if you have an access token from a previous call, only steps 3 to 5 here are required. This approach is especially useful in service-to-service communication such as automated workflows and integrations with security orchestration systems where things need to proceed without user interaction. Again, here is the HTTP message structure for each of the steps on the prior slide, which we'll later implement using a variety of tools. Let's now look at the prerequisites for using MDTI. To use MDTI APIs, users need a license for MDTI Premium and in addition an MDTI API license. To check your licenses, you can go to admin.microsoft.com, then to Billing, then to Licenses, and you can see here that I have a license for MDTI Premium. Note that if a customer buys more than 6 seats of MDTI Premium, then they are eligible to add the MDTI API SKU at no cost. Also, the MDTI API license is applied on a per-tenant basis, so everyone on the tenant will then have access to the APIs. In relation to permissions, unlike many other Graph APIs, the MDTI APIs do not check user-level permissions, and so there are no user-level permission requirements. To use the MDTI Graph APIs, you need a registered app. This can be registered either using the Azure portal or entra.microsoft.com. Either way, the app is set up as an Entra, previously Azure Active Directory, entity. When setting up the app, for supported account types, selecting accounts in this organizational directory is normally okay. The redirect URLs needs to be set and should specify the URL where the authentication server should send the user after they have been successfully authenticated and granted access. Select Add a redirect URI, then Add a platform, then Web, then add your redirect URI. It needs to agree with the redirect URI in the request. And for testing, I often set it to localhost, even though that might not exist. To support authentication using delegated access, that is, access on behalf of a user, in-app registrations, go to Manager, API Permissions, plus Add a Permission, Microsoft Graph, Delegated Permissions, Threat Intelligence, and select Threat Intelligence Read All and add that. Then you need to request administrator consent for that selection. To support authentication using app-only access, go to Manager, API Permissions, plus Add a Permission, Microsoft Graph, Application Permissions, Threat Intelligence, and then again select Threat Intelligence Read All. Finally, you will need to add a client secret. Go to Manage, Certificates and Secrets, plus New Client Secret. Be sure to copy and record your secret because you only get to look at it once. Okay, so this is where the fun begins. Let's test some APIs. There are many tools you can use to access MDTI using its APIs. As shown here, they all exist on a spectrum from testing to production. I'll discuss and demo the use of the 5 tools highlighted in yellow here. That is MS Graph Explorer, MS Graph CLI, Insomnia, VS Code with the REST client extension, and Azure Logic Apps. Having covered all of these, you should have all you need to build the APIs into your production cloud apps. Okay, let's look at MS Graph Explorer and MS Graph CLI or Command Line Interface, which are a couple of the simplest ways to get started with testing and using MDTI APIs. These two tools have a few things in common. With both the hosted MS Graph Explorer and Graph CLI, you can connect to a sample tenant without signing in and experiment with MS Graph APIs without affecting real data. However, in this mode, access is limited to common Microsoft services like users, groups, and directory resources due to restricted permissions. And this anonymous access cannot be used with MSDTI APIs. In this case, you are automatically logged in using delegated access with a demo account login and demo application registration. Alternatively, you can sign in with your own credentials, which automatically connects you to your own tenant and allows you to interact with your own tenant's data. If you have adequate licenses and permissions, you can then use the MDTI APIs. In this case, it still uses the demo application registration. Note that when logging into MS Graph Explorer, your tenant is automatically identified at logon and a demo app registration is used, so there is never any need to provide your own tenant ID, client ID, or client secret. Let's first focus on the simplest approach, MS Graph Explorer. It's a developer tool for exploring MS Graph APIs. It doesn't require any installation and can be used to test common APIs without logging in on a sample tenant. But to use MDTI APIs or to access data in your own tenant, you need to log in. It is a quick and simple approach to start using MDTI APIs, learn about permissions, and access sample queries and more. It's open source, but generally speaking, everyone uses a hosted version at the URL you can see here, which is what we'll be looking at in this presentation. Let's look at a quick demo. First, we'll go to the hosted Graph Explorer, and without logging on, you can see at the top here that we are connected to the sample tenant. We can use common API calls. For example, we can use the me endpoint and press the Run Query button here, which brings up my fictitious user info. But attempts to use an MDTI API, for example this getHostInfo call, will fail, as you can see here. If we log on using our credentials and multi-factor authentication if required, you will first note that we are now connected to our tenant, so now we can use the MDTI APIs. I will retry the same getHostInfo call, and as you can see, it works. Note that for each call we can edit and view the request body and headers, which are both blank for this call, and view the permissions required and the access token currently in use. This is the first of 6 test APIs I will test using each of the tools that I will cover in this presentation. The other calls are getReputation, components, articles, intelligence profiles, and vulnerabilities. I will not go into detail about the functionality of each API. For that, please see the link at the bottom of the page. So, let's quickly run the other 5 of our test APIs. First, getHostname IP reputation. That works, so let's try the other calls. GetHostname IP components. That works and returns quite a bit more data. GetArticle returns article data. GetIntelligence profile returns a large amount of intelligence. GetVulnerability also returns a lot of data. Beyond that, Graph Explorer provides over 20 MDTI sample queries which you can access on the left by going to Security and then down to List Articles and look at the 20 or so below that. In summary, MS Graph Explorer does not require installation and provides a fast, simple and user-friendly approach to get you up and going quickly when testing MDTI APIs with several sample queries. On the other hand, by simplifying things, it limits what you can test. It is also less suitable for scripting and automation. Let's now look at how to use the MS Graph CLI or command line interface with the MDTI APIs. The Microsoft Graph command line interface acts as an API wrapper for all the Microsoft Graph APIs, exposing the entire API set for use from the command line. This means that it can also be used across Entra, SharePoint, Exchange, Outlook, and many more technologies. It is also a cross-platform tool with support on Windows, Mac OS, and Linux. It supports modern authentication protocols and handles a lot of the call flow we discussed earlier, and uses least privilege to minimize risk. It is also open source and receives regular updates to ensure that it supports the latest Graph API updates. It is simple to install using the guidance at the URL on the screen, and when you are done, run mgc --version to confirm it installed correctly. One additional prerequisite I found to be required for this scenario is to enable public client flows. I think this is related to the use of the device code login flow. Navigate to your Azure AD app registration, go to Manage, Authentication, and then Advanced Settings. Change Allow Public Client Flows to Yes. You can use MGC logon --, for the best documentation on how to log on, which I have included here just for reference. Now let's look at how to log on using delegated access, or access on behalf of a user. For this, two strategies are supported: the device code logon strategy, which supports a greater range of device scenarios, and the interactive browser strategy, which requires browser integration. We will look at the default device code strategy. Here I'm showing 3 commands that worked well and delivered 3 very different scenarios. All use the default MS Graph scope because the MDTI API does not check user permissions, and so no additional user permission is required. The first logon command does not specify a tenant ID or a client ID, and thus it logs on to the Graph CLI demo tenant using the Graph CLI demo app. In the second, I have specified a tenant ID but without a client ID, and thus it logs on to your defined tenant but still uses the Graph CLI demo app. In the third, I specified a tenant ID and a client ID, and thus it logs on to your defined tenant using your defined app with all the related permissions. As discussed above, the app will need delegated threatintelligence.read.all permission in this case. Okay. So now let's look at a demo of a logon using the device code strategy. So I've already installed the MS Graph CLI and I will use the Windows command line. So I don't need to show my tenant ID. I have used set Azure_tenant_ID equals to store it in an environment variable so I can reference it using % symbols. I'll enter the MGC login with the tenant ID and the default Graph API scope. You'll note that it asks me to go to microsoft.com/device login and enter the code provided. I then select an account, log in with MFA if required, approve the level of access, click through, and there you go. My MGC login has now returned and we are logged in. Next I will log on specifying both the tenant ID and the client ID. That way it will log me on to my own tenant using my own app registration and its related permissions. By the way, this is a scenario that requires that your app registration has allow public client flows set to yes. Here is that command, and again I need to go through the device logon flow, and with that done, MGC logon has now returned and we are logged in. To test access, I'll run an MDTI API call to get information about the host, riskiq.net. And as you can see, that has now returned successfully. I'll now log out using the MGC logout so we can go ahead and test app-only login. For app-only login, there are 3 strategies available: environment, client certificate, and managed identity. Here we're going to discuss the environment and client certificate approaches. The environment strategy actually supports login via either client secret or certificate, but we'll only discuss the client secret approach. First, you need to set the 3 required environment variables on your PC, as shown here. We can now log in using this command. And now that has completed, I will test my MDTI API again. And that works, so now I'll log out. So now we'll look at the client certificate strategy. First, this requires that you create a certificate, which can be a self-signed one if you are only testing. On this page you can see a link to the guidance for this and the relevant PowerShell commands. Then upload the certificate you create to your registered app. In the Azure portal, go to App Registrations, Your App, Manage, Certificates and Secrets, Certificates, Upload Certificate. Then you can log on with this command. Note that I'm obfuscating my critical data by using the environment variables, but in this case you can put in the client ID and tenant ID in line if you wish. Again, I'll test my MDTI API again, and that works, so great. Using the MGC login command, the access token is obtained and stored. For any subsequent requests, the token is automatically refreshed and included in the headers as needed. This means you don't have to manually handle the token for each request during your session. Also note that we use the graph default scope. Threatintelligence.read.all is not required in the login command because MDTI APIs only check app permissions and not user permissions. The threatintelligence.read.all permission is required for the app. I've also listed a couple of other useful commands here. Okay, so now I'm going to run each of my standard 6 test APIs. Here you can see that for each method I show the HTTP required and the graph CLI command to match. Okay, first we'll get information about a host. Then we'll get reputation for a host based on an IP address. Then we will get what components are installed on a host. Now we will get an article. And we'll get an intelligence profile. And finally we'll get information about a vulnerability. Okay, so this wraps up the Graph CLI section. The Graph CLI certainly has pros and cons compared to Insomnia. I would say that compared to Insomnia, the Graph CLI is less flexible and requires that you learn its unique syntax. But it has the benefit of not needing to learn the Insomnia UI and being more simply scriptable, making it better suited to automation and testing. Okay, let's look at Insomnia. Insomnia is an open source desktop application designed to simplify the process of interacting with, designing, debugging, and testing APIs. It combines a graphical UI with advanced functionality such as authentication helpers, code generation, and environment variables. Install Insomnia from insomnia.rest and get started using the guidance in the docs. The recommended approach is to then test with a sample MDTI API and use Insomnia OAuth 2.0 support to handle authentication, so it then handles the call flow we discussed earlier. We'll use the MDTI hosts function shown here to get started. I don't find the Insomnia UI very intuitive, so I'm going to demonstrate my approach, but there are several other approaches. In my personal workspace, I create a new collection to contain similar API calls. And then, in that collection, I create a new HTTP request, and in the URL field at the top, paste the URL for the API method you want to use. I also suggest that you use environment variables to store sensitive and frequently used text, such as tenant ID, client ID, and client secret. To do this, while in your collection, you can click the base environment and then select this small edit icon. Then add your environment variables using this format. Then, back in your HTTP request, you can insert the environment variables by pressing Ctrl spacebar and selecting the variable you want to use. After entering the URL for the MDTI API being tested, most of the work will need to be on the Auth tab, the Authentication tab. There is nothing else to change on the other tabs. For both Delegated Access and App-Only Access, select OAuth 2.0. Then, as you can see here, for Delegated Access, access on behalf of a user, you need to enter grant type to be authorization code, the authorization URL as shown here, the access token URL as shown here, the client ID, the client secret, the redirect URL. Then under Advanced Options, set the scope to graph.microsoft.com/.default. This means the default scope or permissions for MS Graph. Nothing more is required to use the DTI APIs. And set credentials to InRequestBody. And for app-only access, you need to enter grant type equals client credentials, the access token URL as shown here, the client ID, the client secret, then under Advanced Options, the same scope, and again set credentials to InRequestBody. Now that the authentication is configured, let's finally execute some APIs. I will run 6 sample APIs and I will run each using both delegated access and app-only access. I will start with the hosts call from the previous slides and then call reputation, components, articles, intelligence profile and vulnerability. In each case, the authentication setup is the same as what we just discussed, and all that changes is the URL. Here you can see that for each method I show the HTTP required and the insomnia set up to match. I'll now press send to test this getHosts API call. I'll run this first test in real time. You can see the second timer on the right hand side. For future calls I'll speed it up so it'll be less tedious. It usually takes about 20 seconds to get a logon prompt, and here it is. I'll enter my email, and password, and complete multi-factor authentication. And I'll select that I want to stay logged on. And boom, there is a response which you can see in green and yellow on the right hand side. In all cases, the data is returned in JSON format. As you can see, the majority of the time was spent with the user logon and authentication. Fortunately, for subsequent calls, that can be avoided using the access token, refreshing it as required with the refresh token. You can see the access token at the bottom of the Auth tab. Okay, now let's try Get Reputation. I'm going to press send. And boom, it's back already. You will notice that in this case, I didn't need to go through the logon procedure because I was already logged on from the last call I made. Similarly, if I go to Get Components, press send, and boom, it's come back. Get Article, send, and that has come back. Get Profile, send, and that has come back. Get Vulnerability, send, and that has come back. I'm not going to go into detail as to the contents of the data returned. You can look at that yourselves, but there's a lot of rich data that is returned in each of those cases. Now let's demo the use of app-only access. I will step through the same 6 examples using the app-only approach. The only differences here are on the Auth tab. I've rebooted my PC and a weekend has passed since I demoed Delegated access, so we're starting from scratch. Okay, let's start with Get Info About Host, pressing send. Waiting for a response. And after about 9 seconds we have a successful response. If we look on the Auth tab, we can see we have the access token here. Moving on to Get Reputation, you'll notice that the access token has carried forward, so it won't need to get that again. So we would expect this one to be a little quicker. Pressing send now. And yes, under 2 seconds. Moving on to Get Components, pressing send now. Under 3 seconds. Moving on to Get Article, pressing send. under 2 seconds. Get profile, pressing send, under a couple of seconds again, and finally get vulnerability, pressing send, and again under a couple of seconds. Okay, all those work perfectly and quickly, so that is good. For 23 ready-to-use samples, the MDTI Solutions repo on GitHub contains a Postman collection, and Insomnia supports the import of Postman format files. So let's look how to use this. First, you need to download the MDTI Postman collection.json file and copy it to a convenient folder. Then, I would suggest creating a new collection and use the collection from file option to import the MDTI Postman collection.json file. You will then see 23 examples for you to use. To use these, all you need to do is configure the tenant ID, client ID, and client secret. We previously used Insomnia base environment variables. As imported from Postman format, this collection is designed to use Insomnia folder environment variables, which apply to any APIs in that folder or descendant folders, unless overwritten. You can see that you are meant to add them here on this tab of the root folder. The problem is that in Insomnia, you cannot use folder environment variables on another tab on that same folder, only on items in that folder or below. You can see that issue here where we can see the variables in red with an exclamation mark and an error message on hover. We could create another level in the folder hierarchy to solve this, but I opted for the simpler approach to define the environment variables as base environment variables here rather than folder variables. With this done, all the APIs in this solution just run, giving you a host of examples to use and copy from. For example, get host by DNS name, get reputation for that host, get host info by IP address, get reputation for an IP address, get a list of articles. That brings us to the end of the Insomnia section. Insomnia has excellent support for OAuth 2.0 authentication and browser integration, making authentication and access token handling much easier than with other options. However, by hiding this complexity, it might not help you prepare for translating scenarios into production apps. Support for environment variables is excellent, and the UI has its benefits. Compared to the Graph CLI, it is not as well suited for scripting and automation. Okay, let's now look at how to use VS Code with the REST client extension to use MDTI APIs. Based on the 2024 Stack Overflow Developer Survey, VS Code was the most widely used development environment, with over 70% of respondents reporting it as their primary tool. So many people are going to be comfortable using VS Code. Install VS Code from code.visualstudio.com and then go to the Extensions view to install the REST client extension. For a quick test that it is working, you can use the Star Wars API. To do this, I highlight the request I wish to send and then right-click and select Send Request. And sure enough, it brings me back all the information about Luke Skywalker, what films he's in, what vehicles he's driven, what starships he's been upon. One additional prerequisite I found to be required for this scenario is to enable public client flows. I think this is related to the use of the device code login flow. Go to Azure App Registrations. Go to the Manage section, Authentication, scroll to the bottom to the Advanced Settings section and set Allow Public Client Flows to Yes. Now let's cover some of the basics to use VS Code with the REST client extension. I recommend that you use the URL on this page to read the docs, but here are some of the main things to know. In VS Code, use File Open Folder to open the folder where your request files will live. This opens the entire folder as a VS Code workspace, providing context for all the files within that folder. It also enables Explorer View, version control, and enables some important REST client extension functionality, such as environment variables. In that folder, create a HTTP file and put your requests in that. Requests consist of a request line, headers, and body. The request line can be all on one line, or you can separate query string variables as I have shown here. If you have headers, then the request line should immediately be followed by one or more lines specifying the headers. Then, if you have data in the body, you need to leave a blank line and then after that enter the data you want in the body. Note that typically GET requests pass data as query string parameters, since the intended use case of GET requests is to retrieve data from a server and to be idempotent, meaning that it should not change the state of the server and so should return the same value if run multiple times. Thus, it is safe and easy to cache, bookmark and share HTTP GET requests, which include the query string. POST requests are used to submit data to be processed by a specified resource. They are not idempotent, meaning that each request can have different effects, which is why the data is passed in the body. Environment variables allow you to define a variable once in one file and use it in multiple places across several files. This is useful for things like tenant ID, client ID, and secrets. In your project file, create a folder called .vscode, and in that folder create a file called settings.json and define your environment variables in there in the same manner as you can see here. Note that the $shared variables are accessible from all environments such as local or production or even no environment unless they are overridden. You can then use your environment variables in any of your requests in any of your HTTP files in your workspace. Request variables allow you to use data in a response to set a variable which can then be used in subsequent requests. To do this, you first need to add name metadata to the prior request, making it a named request. After running that request, you can then use the request name to reference a namespace of the returned data and select contained elements such as, for example, access token. And then, as you can see here, that data can then be used in subsequent requests. Okay, that covers the basics. Now let's use what we've covered to log in using delegated access. First, we need to name the request so we can later reference the response and select out the device code. Since VS Code with the REST client extension does not support redirecting a HTML response to a browser, we will use the device code strategy discussed earlier. To do this, use the device code endpoint as shown here. We can then select the device code out from the response and use it to set the device_code variable. Note that the device code will be ineffective until you use the browser to complete the login flow. You can then use that device code in a new token request as you can see here, and after that completes you can extract the token from the response and set a variable. You can then use that token multiple times in multiple requests as long as they are in the same file. Now let's look at a demo of this. I'll highlight the login request, being sure to include the name, right click and select send request. Now the return device code will be ineffective until I log in. Notice that in the return body it says, to sign in, use a web browser to open the page and enter the device code to authenticate. So I'll do that. I'll click on the logon link, paste in the code, log on with my credentials and multi-factor authentication, and then I can proceed. Note that I have a device code variable assignment so I can use it in the next call. It will be evaluated and assigned when I perform the next send request. So I will highlight the token request and select send request. As you can see, it returns the access token and I have an auth token variable assignment so I can use it multiple times in multiple subsequent requests as long as they are in the same file. Also note that the response does not contain a refresh token. Note that I don't need to obfuscate the device code or access token because they'll be expired long before this video is published. The app-only login request is the same as we have used before, except for the use of REST client environment variables and that we name the request so we can later reference the response and select out the authorization token. Later we can then use that variable to insert the token as required in later API calls. Let's now look at a demo of the app-only login call flow. I'll highlight the login request API, being sure to include the name of the request at the top. I'll right-click and send request. As you can see, the access token is returned and, as expected, no refresh token. We can then test with our getHostInfo test API using the auth token to request variable to carry the access token forward. And as you can see, that works. So let's run through the other test cases. First, get hostname IP reputation. That works. Next, get hostname IP components. That works and returns quite a bit more data. Get article returns article data. Get intelligence profile returns a large amount of intelligence. And then get vulnerability also returns a lot of data. In summary, if we compare VS Code with the REST client extension to other options we've discussed, I think the main benefit is that it provides an integrated environment, and if you're already using VS Code, the REST client extension integrates seamlessly, allowing you to manage your code and API requests in one place. The extension is lightweight and doesn't require a separate application. It also provides nice support for environment variables, making it easy to reuse commonly used variables and switch between different environments. The syntax for building requests is also intuitive and developer-friendly. Compared to Insomnia, it does lack some more advanced features and does require that you manage OAuth 2.0 login and token handling yourself. Okay, let's look at an example of using MDTI APIs with a low-code dev tool. In this case, we'll look at Azure Logic Apps. Azure Logic Apps is a cloud-based service that allows you to automate workflows and integrate apps, data, services, and systems. It provides a visual designer to create workflows with minimal code, connecting various services like Office 365, Azure services, and third-party applications. Logic Apps is ideal for automating business processes, complex workflows, and data integration. Azure Logic Apps is representative of many low-code solutions available. The key takeaway here is that such tools can be used with MDTI APIs. In the interest of time, I will not do a full demo of this tool, but I will try and point you in the right direction. You'll need an Azure subscription and the required permissions. Then in the Azure portal, create a Logic App resource and then configure the Logic App. Go to Workflow and add a workflow. Select Stateful if you want to use a recurrence trigger to schedule execution. Give it a name, then open it. All workflows need a trigger, so select Add a Trigger. I use a recurrence trigger and scheduled it to run every 5 minutes. Then add parameters to contain your tenant ID, client secret, access token, etc. Or if required, select a more secure option. Then back on the designer work surface, add an action, select a HTTP action. As required, you can then add URL, headers, query parameters, and body data. Click on the Settings, Code View, and Testing tabs for more options. You then need to configure the HTTP actions to log in, get, refresh, and store access tokens as required, and then to make the desired calls using the stored access token. In summary, low-code solutions like Azure Logic Apps are a good option for automating recurring business processes, complex workflows, and data integration tasks. Okay, let's move on and talk about the Microsoft Graph SDKs. The Microsoft Graph Software Development Kits, or SDKs, are designed to simplify building high-quality, efficient, resilient applications that access Microsoft Graph APIs. The SDKs include two components. The Service Library contains models and request builders generated from Microsoft Graph metadata. The Service Library provides a rich, strongly typed and discoverable experience when working with many of the datasets available in Microsoft Graph. The Core Library provides features that enhance working with all Microsoft Graph services, embedded support for transparent authentication, retry handling, secure redirects, and payload compression. Also, paging, creating batch requests, etc. The SDK is available for a wide range of languages, as you can see listed here. The other option is a Kyoto-generated client. Kyoto is a command line tool developed by Microsoft for generating API clients to call any open API described API. In some cases, it is beneficial to use a Kyoto-generated client instead of the Graph SDK. For example, if a developer uses only a small subset of the Microsoft Graph APIs and wants to minimize the overall install size of their app, they can use Kyoto to generate a smaller client library. Be aware that Kyoto creates source code that you'll need to compile with the rest of your application. In summary, if you're using any of the supported languages to develop any apps that access Graph APIs, including the MDTI APIs, I'd strongly recommend that you use the Graph SDK or a Kyoto-generated client. Doing so will help you generate high-quality, efficient, and resilient applications. Okay, so to wrap up, the MDTI APIs allow you to operationalize the integration of the wealth of threat intelligence MDTI brings to bear with your tools of choice, without relying on the user interface or UI. This can enrich your tools of choice with more actionable intelligence like articles and intel profiles, indicators of compromise or IOCs, and reputation verdicts, as well as providing enrichment data including passive DNS records, cookies, components, and trackers. That brings me to the end of this presentation on the application and use of Microsoft Defender Threat Intelligence APIs. Thanks very much for watching. I sincerely hope it was helpful, and if it was, please give it a thumbs up. I also hope you are able to watch my other videos in this series. Thanks again, and all the best.